Alright, so today we're doing the notes for 16.1, Properties of Logs. There's three properties that we're going to use today when we expand and condense logarithmic expressions. And so we'll start by going over those. The first one is called the product property. And so it says when you have log base b of a product, right? This is like m times n. It can turn into log base b of m plus log base b of n. So if it's multiplication, multiplication becomes addition. And so it's important that you see that sign right here. Something else to note is if there was a third base here, like another variable or perhaps a number, the number of bases indicates how many terms you'll have in your expression. So if there was a third thing, sometimes there can be 1, 2, 3. So there could be another part to your expanded expression. The quotient property is the second property. And that one says that if you have log base b of m divided by n, so if this is division, division becomes subtraction. So you can expand it to be log base b of m minus log base b of n. And then the last one's the power property. And you see how I've circled the n and I've drawn it out front? So if you have log base b of m raised up to the n exponent, the exponent can come out front and it becomes a coefficient. And so it turns into n times log base b of m. So these three properties, 1, 2, 3, are going to allow us to both expand and condense logarithmic expressions, and so that's what we'll be doing in the notes today. So here in this first section of notes, the directions say to expand. We see that right here the word log has only been written once. So log base 3 of the product 4 times x times y. There's 1, 2, 3 parts here on the inside. So when I expand that, it's going to become log base 3 of 4 plus, right, because it's multiplication, and we set up here that multiplication becomes addition. So log base 3 of 4 plus log base 3 of x plus log base 3 of y. And normally these three things would just be written out next to each other in a line, but I didn't have enough room to fit it over here, so I opted to write it underneath. Then you want to check 3 raised up to an exponent doesn't give you 4, not an integer exponent or a fractional exponent anyways. So this can't simplify any further, even though it just has numbers. And then you look on all the bases and you make sure that none of the bases have exponents that could come out front as coefficients, and so they don't. And so that's your answer to the question. Log base 3 of 4 plus log base 3 of x plus log base 3 of y. On B, right now, so it's the common log of the square root of 10, or the common log of the square root of x. And so for this one, we want to start, and instead of having it be written as the square root of x, we're going to write it as x to the 1/2 exponent. And so to expand this one, there's just the one base, so we're not going to write it out with pluses or with minuses, but this 1/2 that's up in the exponent can come out front, and again, it becomes a coefficient. So your answer for this one is going to be 1/2 times log of x. On C, let's see, there's two bases, so our answer will have two terms. So this one's the natural log, so ln of x squared plus ln of y. And then you want to check each part to make sure there's nothing else that you can do. And on this one, if we're expanding it, this 2 can come out front. And so it's going to be 2 times the natural log of x plus the natural log of y. And I know sometimes my l's look like 1, so just remember that's ln. And then lastly on letter D, this one's going to have a couple things we need to do. So you see how this one here has a quotient, right? So it's division. So we're going to do, let's see, log base 5 of a, so that's the top part, and then it's going to be minus, because this is in the bottom, log base 5 of 3b, and it's both of those things that are still there. Now remember, this is a product, however, and so we can further expand it, so it's going to be log base 5 of a minus log base 5 of 3 plus log base 5 of b. And then you want to be careful, because this negative sign that's right here is going to apply to both of these parts, so you have to distribute the negative. What you'll wind up with for your finished answer is log base 5 of a minus log base 5 of 3 minus, because you're distributing that negative, log base 5 of b. And then before you decide that that's your final answer to the question, remember you want to look at all three parts and see if any of them can simplify further or evaluate further. But 5 doesn't raise up to an integer or fractional exponent to give you a 3, and so this one can't simplify any further. So we'll just leave our answer like that. So when the directions say expand, you're starting out with 1 log or 1 ln, depending on the problem, and you're expanding it so products become addition, exponents come out front as coefficients, and then quotients turn into subtraction. The number that's on the top will be positive, and then the ones that are on the bottom will both be negative when you're doing quotients. When you condense logarithmic expressions, you're trying to do the opposite thing. So here you see log base 3 and log base 3 written twice. We're going to collect these back together and condense them to write them as a single logarithm. So you'll notice that the bases will match, so these will always match 3 and 3. So log base 3 of 18 minus log base 3 of 2 is going to turn back into log base 3 of, and then you want to stop and think, minus, when it condenses, is going to give you division. So this is going to be 18 divided by 2. And then it says to simplify if necessary. So we're going to keep simplifying on this one. It's going to turn into log base 3, 18 divided by 2 gives you 9. And then here we want to stop and think back to the 15.1 notes. Log base 3 of 9 can further simplify. Remember that logs equal exponents, right? So log base 3 of 9 is asking you to stop and think 3 raised up to what exponent gives you 9. Remember how we did that the other day where we put an x over here and then we said 3 to the x equals 9, and we stopped and we thought about this. So 3 to what exponent gives you 9, and so it's 2. So log base 3 of 9 further simplifies and it becomes just 2. Remember from the 15.1 notes, we didn't write x equals 2 because we add in this x just to help us, it's like a tool, right? Just to help us think about the problem. And so this whole expression, when you condense it, condenses to give you just the value 2. It's not always going to happen that it turns into just a number, but it will happen anytime you have just numbers left over, no exponents, or rather no variables. You want to stop and think about if it can simplify further. And so we'll see that come up again in future places on the notes today as well. Let's see. On this one, so we're going to condense it, 6 times the natural log of x plus 4 times the natural log of y. So I'm going to start by putting the exponents back where the exponents would go. So it's going to be ln of x to the 6th plus ln of y to the 4th. And so by putting the exponents back where they go, that's going to allow us to finish simplifying this one. Remember that addition becomes multiplication when you condense. You're just doing the backwards of what we did up above in the previous example. And so for this one, my answer is going to be the natural log of x to the 6th, y to the 4th written out as a product. And sometimes you'll see that with parentheses around it, so it's okay to include those there as well. Let's see, on C, so the natural log of 24 minus the natural log of 4 minus the natural log of x. So there's a couple different ways that we can think about this. Remember from the previous example, when you see minus, it means it's going to be division. One way that you can approach this, right, so there's 3 parts, they're all going to combine back into 1. So it's going to be the natural log of 24 goes in the top, and then see how it says minus the natural log of 4 minus the natural log of x? That means that the 4 and the x are both going to go in the bottom of the expression. You could undo the distributive property to see why these two become a product here in the bottom. Now for this one, it does say to simplify if necessary, so it's going to be the natural log of, and then right here, the 24 and the 4 can each divide with one another, so you would want to do that simplification here as well. The 24 on the top can divide by the 4 in the bottom. 4 goes into 24 6 times, and so we're going to get ln for the natural log of 6 over x as our answer for that one. That's our fully condensed answer. Last one, remember I'm going to look for coefficients out front because the coefficients out front can flip back up and become exponents. So this is the common log of 9 plus, when the 3 comes back up here, 2 to the 3rd, and then 2 to the 3rd gives me 8. And so I get all of that simplifying done here, and now I'm going to stop and look at what I have. So addition becomes multiplication, so this is where you're just going to write it once. The 9 times 8 is going to go up in the top because addition becomes multiplication when I condense, and then the 3 will go in the bottom. And then, remember, log without a base is the common log, so it's log base 10. We just don't have to say the 10. 9 times 8 is going to give me 72 in the top and 3 in the bottom. And so for this one, when you're all done, you'll do 72. You'll divide that by 3, and then we'll just double check and make sure that we got the right answer to that question. So 72 divided by 3. Yep, in fact it does give you 24, and so you'll get the common log of 24 as your answer for this one. This is 10, so 10 doesn't raise up to an integer or fractional exponent to give you 24, and so you'll just leave your answer like that. These final two examples are part of the same condensed question that we were just working on. They look a little bit different because they have decimals, but remember your first goal is the same. So there's two logs that you see, and so you're going to condense them back together into one. Remember that subtraction becomes division when you condense them. So this one's going to be log base 2 of 44.8 divided by 1.4, and then you do want to continue simplifying. So now I'll divide these two numbers. And so that's going to give me log base 2, 44.8 divided by 1.4 gives me 32. And then whenever these are numbers, you want to stop and think to see if you can further simplify it. 2 raised up to what exponent gives you 32, so you stop and think. And so for this one, 2 times 2 times 2 times 2 times 2, 2 to the 5th power gives me 32. And so this whole expression, when I condensed it and then I finished by simplifying this part, I get just 5 as my answer to the question. So sometimes when your base and when your argument are both numbers, right, instead of variables, sometimes it can further simplify and sometimes it can't. It just depends on the question. On the last one, you're going to start by doing the same thing, except on this one, do you see where it has the plus sign, right? And so it has a plus sign, and so you want to remember that this one, when you condense it, addition becomes multiplication. So it's going to be log base 4 of 25.6 multiplied by 2.5. And so you'll start by multiplying them. That's going to give you log base 4, and when you multiply these two together, you get 64. And then whenever these are numbers, you want to stop and think to see if you can further evaluate that. So you want to stop and think, do logs equal exponents? So does 4 raised up to some exponent give you 64? And you stop and think, and it does. And so on that one, your final answer will be 3. That's the fully simplified version of this, condensed first and then fully simplified. This final example on the notes page is just giving you some extra practice with expanding logs. So it tells you that log base 6 of 5 is approximately this value, and log base 6 of 8 is approximately this value. And it wants us to evaluate the logarithmic expressions that were given. And so we don't right now know how to type in log base 6 of 5/8 into our calculator, because remember the log button on your calculator is always log base 10 and this is log base 6. And so what you want to do on this one is you want to try to finagle it and work it out so that you can use these two decimal equivalents that they gave you to answer the question once you've expanded the expression. So watch on this one. You don't know what log base 6 of 5/8 is, but you know that division becomes subtraction when you expand it. So I can start by expanding this one to be log base 6 of 5, and then division becomes subtraction, right? Minus log base 6 of 8. And then if you look up at what you were given here, you were given log base 6 of 5, so that's approximately 0.898. And then you were given log base 6 of 8, that's approximately 1.161. And so then what you can do is you can subtract them from each other. So you're going to do this value minus this value, and that will give you 263. That will give you the answer to the question. And so your first goal when you're doing this is you want to write them in some kind of expanded form where you break it down so that you know different parts of it that you can include. So like, let's do this one. They don't give us 64, they only give us 5 and 8, but 8 times 8 gives me 64, right? So I'm not going to multiply this times itself. I need to expand the expression. So this is going to turn into log base 6 of 8 times 8, and then you know that when you expand it further, when you write it with the two logs, multiplication becomes addition. So this is going to be log base 6 of 8 plus log base 6 of 8, and then that's one of the ones that you're given. So you're trying to work the numbers out to break it down so that you know one of the parts. 1.161 plus 1.161, and so for this one you get 2.322 as the evaluated answer for the question. On letter C, they give you the number 40, and 40 isn't one of the ones that they give you, but if you notice 5 times 8 gives you 40. And so I'm going to break this one down. Let's see, log base 6 of 5 times 8, and then we know that multiplication becomes addition when you expand it. So it turns into log base 6 of 5 plus log base 6 of 8. And so for this one, I'm not subtracting the values together, I'm adding them together to get the answer to the question. This is 2.059. And then lastly, I think that the final one's a little bit tricky. There's a couple different ways that you can figure it out. You're trying to get 1/5 as your answer, and you have to do that using a 5 and using an 8. So one way you could do it is you could try to make 1/5 out of a 5 and out of an 8. And so it's a little bit tricky to wrap your head around this one. But so log base 6 of 8 over 5 times 8. Okay, let me talk about this one. So the reason why I picked these numbers kind of randomly is because 8 over 40 would reduce to give you 1/5. So if you multiplied the top and the bottom by an 8 on this one, you could make the 1/5 out of the two numbers that they give you. So when you expand it, let's see, it's going to be log base 6 of 8 minus log base 6 of 5 times 8. And then remember, this product will become addition. So it'll give you log base 6 of 8 minus log base 6 of 5 plus log base 6 of 8. And then you have to distribute the negative. So that'll give you log base 6 of 8 minus log base 6 of 5 minus log base 6 of 8. And then the log base 6 of 8 will actually cancel each other out, which you can do either now or later, that's fine. Let's see, log base 6 of 8 is 1.161, so these two will cancel, and so you'll get negative 0.898 as your value for this one. So you're trying to creatively, again in this section, you're trying to creatively come up with numbers that you can use to represent the argument using the values of the approximate values of each of these logarithmic expressions that you're given in the beginning.